Hello and welcome. In this video we are going to take a quick look at a admittedly somewhat out-of-date firewall called Iptables. So we'll learn how to configure this, again, somewhat obsolete firewall on your Linux servers so that you can start to control the traffic that's allowed to reach your machines. Admittedly, you should absolutely not be using this particular firewall on a production server, but this is very useful as a first firewall to learn to help you understand how a firewall is going to deal with your traffic. It helps conceptualize what they're going to do. Now, what a firewall really is a filter that is going to sit between your network connection and the rest of your system, effectively allowing you to, again, filter the traffic that is allowed to actually reach your machine. So any service, any data that is trying to send or receive with your machine has to go through this firewall. Now, these days, the typical network protocol for this is TCP/IP, so we're dealing with network packets, and a firewall looks at the headers of these packets. It is not going to look at, or at least Iptables is not going to look at any of the details inside, but it looks at data like the IP address that sent this packet, the IP address it's addressed to, the port that it's coming from, the port that it's going to, the type of service that it happens to be. And your firewall is going to examine those features to decide, is this traffic that I want to actually allow to reach my machine, or that I want to allow my machine to send out, or not. So how Iptables works is a packet shows up at Iptables, and it will have to pass through one or more rules. Those rules have conditions, things that they're looking for in a packet. And to go back to the things I was mentioning on the previous slide, things like the protocol that it's using. Is it a TCP packet? Is it UDP? Is it ICMP? The IP address that sent it, the IP address it's being sent to, the port that it's using, things like that. So it will look at, each rule will have one or more of those conditions in it, and if that packet matches all of those conditions, then this rule also includes an action to take. And some of the actions that you'll see will be accept, drop, and reject. Accept means let this packet through. Allow it to do what it's trying to do. So if it's being sent to our machine, allow it to actually reach our machine. If it's our machine that is sending out and this rule says accept, okay, allow that packet to leave this machine and go out onto the network. Drop is the opposite of that. It's do not allow the traffic to happen. So it's coming in and it's traffic that we don't like, so we stop it. We throw it away. Reject also does that, but with an extra step that it actually sends a message back to the sender saying, I blocked this. I'm rejecting this. I'm not allowing this packet through. If the packet didn't match that first rule, it would move on to the next rule and be compared against the conditions in that rule. If it matches, okay, that rule has an action. If it doesn't match, you move on to the next rule, and the next, and the next, until eventually, potentially, you might actually run out of rules. In which case, there is a default policy, an action to take if you have a packet that doesn't match any of the rules that you have. And that will be one of accept, drop, or reject. And you take these rules and you combine them together or put them in a list called a chain. And a chain is just a collection of rules that deal with particular circumstances of traffic. Now there's quite a few different chains organized into several different tables. I'm only actually going to look at one. This is really just intended to be an introduction. I'm probably not going to end up doing videos on the more complicated chains or adding custom chains, because again, you really shouldn't be using this as a firewall on a production server anymore. So I'm only going to look at 3 predefined chains: input, output, and forward. Input is for packets that are arriving at and addressed to this machine. So if somebody tries to open an SSH connection to our machine, when that packet shows up on our machine, it goes into the input chain to decide, do we want to accept this or not? Output is packets leaving this machine. So that could be when our machine responds to that SSH connection attempt, assuming it made it through. When we respond back, we are sending a packet out through output. So we're sending it to whoever originally tried to talk to us. Or if we try to install a package, the first thing that happens when you run that yum or dnf command is your machine sends a packet out to try to, well, actually several packets, to try to reach an update server. Well, a repository to see if there's any packages that need updates. So it would send packets out through output. Forward is for traffic that is arriving at this machine but isn't actually addressed here. So with my students, the way we set up our networks is we have a host machine and it has several nested VMs inside it. When those VMs want to reach the outside world, they have to pass their traffic through that host machine, and it sends it on to the outside world. So that is going to show up in the forward chain of that host machine. And to illustrate how the rules work a little bit, so a packet shows up at our machine. I'm going to assume this is input, although again, this could be any one of input, output, forward, a custom chain that you create, or one of the other predefined chains that we're not looking at. So that packet shows up, and it gets compared against the first rule in that chain. And that rule, again, will describe several conditions that it's looking for, features of a packet that it is trying to match. If this packet matches all of those conditions, that rule has an action, we take that action, and then that packet is done. Well, generally speaking, it's done. There are a couple of actions that don't actually finish dealing with that packet, but again, this is supposed to be introductory, so I'm not going to describe that. With accept, drop, and reject, the packet is done. If that packet didn't match that rule, there's some condition that was different, the packet gets passed to the next rule and compared against the conditions in that rule. And if it matches all of those conditions, we use the action for that rule, accept or reject or drop. If the packet didn't match those conditions, it gets passed to the next rule and the next and the next, until eventually, again, there's a default policy for this chain, sort of a last fallback action that if none of your rules say what to do with this packet, you still have to do something with it, and that default policy is that something. Now the command we're going to use to interact with iptables is iptables. The stuff that we're doing right now, where we are just trying to display information, we should be able to do as a regular user, but any of the commands that we'll look at in the next video, where we would be making changes to our iptables, would require elevated permissions. And per usual, like I always say, before we start making any changes to anything on our machine, we are going to examine what the current settings are first. And these commands would also work after the fact if you wanted to double check that what you've done has actually worked. So the common option we're going to use is iptables-L. This is going to list your input, output, and forward chains, and potentially other customized chains if you had created them, but we're not doing that. So I'm going to head on over to my C8 demo machine. I'm going to point out for anyone who's wondering, no, Iptables is not the standard firewall on CentOS 8 or CentOS 8 Stream or anything newer. It wasn't the standard firewall on CentOS 7. But before I did this video, I installed Iptables and set the machine to be using it. There it is. It's running. I will point out just one thing: if you are trying to convert a machine from using Firewall D to Iptables for some reason, your machine cannot be running both at once. It can only run Firewall D or Iptables, and if you leave them both set to enabled, Firewall D is going to take precedence because it's the firewall you should be using. So I did stop and disable Firewall D, and I installed Iptable services, started Iptables, enabled Iptables. But with that out of the way, if we Iptables-L, oh, okay, we do need elevated privileges for this. That tells you how frequently I use this tool anymore. And I will make my window a little bit wider to try to make this all show up each on one line. There we are. And we can see the three chains that I mentioned: input, output, and forward. And each one is showing us its default policy. So if a rule or if a packet doesn't match any of the rules in the chain, in fact the output chain has no rules, the action that we take is accept. And this is just the default that's preset in Iptables. In the next video, we'll see how to change that. The forward chain, well, we can see there's one rule in there. We can see the target for it, we can see some conditions that it's trying to match, and potentially some other options for it. So this includes information like the protocol that we're looking at, the source address of who is sending this traffic, the destination address of who this traffic is being sent to. So if a packet came in that, while I'm highlighting the forward chain, so we'll deal with that, if somebody sent a packet to this machine and the real destination was a different machine, well, that packet would get compared against these conditions, and if it matches these conditions, it would get rejected. We would send a message back saying, no, I'm not sending that packet. In our input chain, this will allow me to describe the order of rules again. If a packet shows up, it would get checked against the conditions in this first rule first. If it matches these conditions, we would accept that traffic. We would allow that into the machine. If it didn't match these conditions, the packet would get passed to the next rule in the chain, which is looking for ICMP traffic, sent from anyone to anyone. So if somebody tries to ping my machine, okay, that's accepted. That traffic would be allowed in, and then that's it. That packet is done. We don't need to look at any more rules. But maybe it's SSH traffic, and it's not related or established, that I will talk about in a minute. So it would pass through the first rule. It would pass through the second because SSH traffic is not ICMP traffic. This third rule looks like it would catch it, but there's something I will show you in a minute that, no, this rule doesn't actually catch that SSH traffic. It does actually get past this fourth rule that is looking for TCP traffic sent by anyone, addressed to, well, anyone, but if it arrived here, it would actually be addressed to this machine, and that is being sent to the port associated with the SSH service. That is TCP port 22. So if somebody SSH'd to this machine, that would be accepted. Other traffic, though, might hit this last rule that just says reject anything that's left. Now, we had that third rule there that looked like it should have accepted pretty much anything from anywhere, which is just an absolutely terrible rule to have. And that's where we're going to add in this option iptables-l-v to make the output more verbose, to list more information about each rule. And of course that made my output a little too wide, so I'll shrink it and expand the window a bit. And now that'll fit on one line again. So this added several extra columns to our output. It added the incoming and outgoing interfaces, so we can start matching traffic to a particular interface that it arrived on. And this is the secret as to why that third rule doesn't actually allow just anything into my machine, because it is looking for traffic only coming in on the loopback interface. That is that pseudo interface that this machine is allowed to use to talk to itself, but that nobody else will be able to reach. It also added columns over here on the left for packets and bytes, so we can see how many packets matched a rule and how many bytes that traffic represents. This actually gets really, really handy if we're trying to test out our rules to see if they work. We can send traffic that should match them and see if the packet counter goes up. Now, if we're trying to look at just the input chain, or just the forward, or just the output chain, we don't necessarily want to see all of this. So when we say -l, we could follow that with the name of a chain. If I was only interested in input, I could iptables-l input-v. And now it's only going to show me my input chain. Or if I was only interested in output, iptables-l output-v. And I only see my output. So very handy way to filter what I'm seeing so I can focus on the important information. I realize I didn't put this in the slide, but another really handy option, which I will switch back to looking at input for, is -n to make the output numeric. So instead of trying to tell me the destination port associated with SSH, it's just going to show me a port number. Because guaranteed there are more services than you will remember the port numbers for. So sometimes it will be handy to just be able to say, tell me what port number that is. So it'll show me 22. And the source and destination, since those were anywhere, it is literally any address. If we did have a rule that specifically referred to one IP address, one unique machine that we could resolve the host name for, the normal display would show that host name. The numeric display would show the individual IP address. Now, I mentioned related and established a few minutes ago and said I would come back to them. This is probably a good time to do that. There are three states that you will typically see a packet in. There are actually several more, but they're less common. Again, this is introductory. I'm only going to talk about three. And those are new, established, and related. A packet that is new is the first connection in, or the first packet in a communication. So when we SSH to a machine, that first packet where we try to make that connection, that packet is new. But as soon as the server responds back to us, now every other packet in that communication is established. We've effectively said hello, the server has responded back, we have ongoing established communication. So a lot of your traffic is going to show up in established. And that's why we have this default rule pre-set up for us that just says, if this communication is established from anywhere to anywhere, any protocol, just let it keep happening. We already accepted the initial part of the communication, let the rest of the communication happen. That does also catch related, which is the third major state you'll see a packet in. That shows up for packets when you have an established connection, and because of what that connection is doing, we open up another connection. There's a version of FTP that is a really good example of doing this, where it has one connection that it creates for being able to send commands and receive the output of those commands. But as soon as you say, I'm going to transfer a file, it actually opens a second connection to do that file transfer while still keeping the first one open to allow you to run commands and see output. And that second connection it creates is related. It only exists because we already have that first connection. So again, this first default rule here that says accept all related and established traffic regardless of where it's from or where it's going to or what interface it's on. Very handy rule to have. Don't delete this rule unless you're in a super high security environment. This just says if we're already talking to the machine or another machine is talking to us, let that communication keep happening. The second rule is looking for ICMP traffic coming in on any interface, addressed from anywhere, addressed to anywhere. Although it would, of course, have to be addressed to this machine to arrive here. So, yeah, anybody on the internet can ping us. That's honestly not great, and in my next video, we are going to get rid of this rule. This third rule is looking for any protocol traffic. If it's coming in the loopback interface from any source address to any destination address, this allows the machine to talk to itself, and there are a number of services and programs that need this. The machine needs to be able to talk to itself, so do not touch this one. This fourth rule that we can see one packet has matched is looking for TCP traffic coming in on any interface. Outgoing interface doesn't make any sense because this is the input chain, so we can kind of ignore that. From any IP address, addressed to any IP address that, of course, this machine has. So, new packets that are addressed to TCP destination port 22. That is, if somebody starts an SSH connection to this machine, allow that to happen. And we will reject any other traffic that happens. Oh, I almost forgot to talk about this one, -- line. All this does is add a column on the left to display what rule number this is. So you can use it in combination with any of these other options, and all it does is add this extra column on the furthest left indicating this is rule 1, this is rule 2, this is rule 3, this is rule 4, and this is rule 5. And that may seem very trivial. I'm sure you can look at this and say, yeah, that's rule 1, 2, 3, 4, 5, right? When you have a chain that's only 5 rules long like this, that is super easy to do. But when you have a chain that maybe is 30 rules long, and you're trying to do something to rule number, well, I think that's 27, but I'm not absolutely certain. I need to count that. Guaranteed, when you're sitting there trying to count, that is when somebody is going to interrupt you and make you lose count, and then you'll have to start that all over again. Adding in the line number to be able to just quickly say, that's rule number 27. Very, very handy. I did mention in there the default policies. These are actions to take if a packet makes it all the way through your rules and none of them have matched that packet. You do need some last action to take. Now, the default setting here is accept. That is, if a packet makes it through all of our rules, we're going to say, okay, allow that traffic. And that's a terrible idea, which is why the last rule in the chain there is actually rejecting absolutely everything. But, well, anything that makes it to that rule. So anything we didn't explicitly say, yes, allow this traffic. But honestly, even rejecting that unexpected traffic is maybe not the best idea on the modern internet. There's a really important distinction between drop and reject. When we receive a packet and drop it, we just throw it away. We don't respond. When we reject a packet, we're sending a message back to the originator saying, I'm blocking this traffic. I'm not allowing it through. When you do that, you're letting that other machine know that you exist. And, within your own network, that's probably fine, because it's you or another admin trying to establish a connection between machines, and just maybe using a protocol that you didn't set up to be allowed through the firewall. But if it's, I don't know who to pick on, someone from the former Soviet Union maybe, say that Internet Research Agency trying to ping your machine or SSH into your machine, you maybe don't want to even let them know that your machine actually exists. You want, when their traffic shows up, you just throw it away. And hopefully they move on and start trying to break into somebody else's machine. If you respond, you let them know there really is a machine there that maybe they will spend some time trying to compromise. So what we've quickly looked at, half an hour later, in this video, is the basics of an older firewall that used to be used on Linux machines called Iptables. And there was much, much more that this firewall could do, but this is really just here to introduce you to the basics of how this firewall works and get you to start thinking about how traffic arrives at your machine. Even just the basic simple stuff that we've done here allows you to see what traffic is being allowed through your firewall. In my next video, we're going to look at how we can change these rules, change these settings, so that we can better determine what traffic we actually want or don't want, so we can better protect the machines under our control. So thank you, and I'll see you there.